Hi, and welcome to this crash course on linear relationships and how to represent them. So in this first video, we're going to be focusing on secondary 2 and secondary 3 material, and we're going to be looking at how to find the slope, or the rate of change as we also call it, of a line using a graph, table of values, and a word problem. In the second video, that's going to concentrate more on secondary 3 kind of materials. So we'll be looking at how to find the equation of a line again using a graph and a table of values, as well as a word problem. But we'll also be looking at how to find other values once you have the equation of a line. In a linear relationship, there are always two variables, right? And one is going to be dependent on the other one. So we call them the dependent variable and the independent variable. So it means that the dependent variable is going to change because of whatever that independent variable is doing. Now you'll notice that the independent variable here, we've labeled it on the x-axis. This is really important because it's always going to be labeled on the x-axis. That's where we graph the independent variable, and the dependent variable is always going to be on the y-axis. So you can see that already put in for us here. As we start to fill in our ordered pairs, you're going to see that when you connect your dots, they create a straight line, and this is just what happens with a linear relationship. It is literally a straight line, like this one right here. Now, just from looking at the image, do you predict that the slope of the line is going to be positive or negative? That's right. If you guess negative, that's correct. You can see that when we read this line from left to right, the line actually goes down. You can almost picture yourself sliding down it like on toboggan in the winter, okay? That is what negative slope does. So looking at it left to right and seeing that the slope is going down like this, we know that the slope is negative. All right, so I've got a situation here for you. Someone is earning $15 an hour at their job. This means we have two variables. We have the number of hours that the person is working and the money that the person is earning. So I have a question for you. The number of hours a person works, is it the dependent variable or the independent variable in this situation? So the answer is false. In fact, it's the number of it's the money earned that is dependent and the number of hours that is independent, because you can actually calculate how much money you're going to earn depending on how many hours you worked. Let's just take a look at how that would look in our table of values. All right, so if we know that the person is working 0 hours, which is already, we've identified that as our independent variable, then we know that they're going to be making 0 money. All right, makes sense? If the person works 1 hour, they're going to be making $15. If the person works 2 hours, they're going to be making $30. If they work 3 hours, they're going to be making $45. And we can continue this pattern for any number of hours we want. So let's say the person works 7 hours, they're going to be making $105 as we continue this pattern. All right, now this table of values here has actually generated a set of x and y coordinates that we can now plot on our graph. So I'm going to show you what that'll look like. There we go. Here is our graph, or the beginning of our graph, okay? You see that the points have been plotted here for us, and if we actually draw the line, you see that we've got a straight line. It starts at the origin, right there, and then it's going upwards. That upward increase here is what we call positive slope. So this is actually showing it, if you think of how our negative slope was going downhill, well, this one, when we go left to right, is going uphill. And you can actually see the pattern reflecting here of our increase of $15 for every 1 hour we're working. All right, so the answer is false. And if you think about it, the amount of money that somebody earns is actually going to depend directly on how many hours they work. So you can see it again in how we've labeled our axes here. Remember from earlier that we talked about how the number of hours is, what's graphed on the x-axis is going to be our independent variable. What's graphed on the y-axis, that's going to be our dependent variable. And you can actually see that number of hours has already been graphed for us or labeled for us. And the money earned has been labeled for us. And the money earned is sitting on the dependent axis. So let's just start filling in this table of values and see how that would work. If we think about a person actually working this job, that means that if they work 0 hours, they are making 0 cash. If they work 1 hour, then we already know they're going to be making $15. If they work 2 hours, they're going to be making $30. If they work 3 hours, they're going to be making $45. And this pattern is going to continue. We can basically use that same pattern to figuring out their salary at any number of hours that they're going to work. But I want to know what they're going to be making at 7 hours. So if I continue that pattern, I find out that they're going to be making $105 after 7 hours of work. All right. Now, what we've done here in filling out the table of values is actually generated a set of ordered pairs or points that we can now graph. And you can see that I've gone ahead and graphed those right there for us, which then we can connect the lines. And unsurprisingly, it makes a straight line because we're talking about linear relationships, and linear relationships mean lines. So here we go. Here's our straight line, and you'll notice that it's going up. Well, that increase is normal because you can actually see that the salary is increasing every single time we go up in the number of hours that are being worked. So that gives us this increasing line here, the line that's going up, which is also positive slope. Now, we can push this a little bit further on that slope. And look, you can see the slope. Okay, we talked about how slope can be called slope or rate of change. Well, the rate of change is sort of reflected here because for every $15 the person is working, or for every $15 the person is making, they've worked an hour. So we've actually got this rate of change of $15 per hour worked going on here. So $15 per 1 hour worked. And that's shown again here in our graph, okay? If we've got that rate of change reflected directly in how steep our line is. That's why we call it slope, okay? Because the slope is how steep, it's the incline of that line. So you can see here that when we look at how the y-axis is changing, we call that the rise, and that's how much money is being made. And we compare that to how it's changing on the x-axis, which we call the run, right? So, and when we take the rise and put it over the run, we can actually use that to calculate our rate of change or slope, which tells us how to set the line. All right, so let's look at another graph. Imagine we're trying to find the slope of this line. I got a question for you. True or false? The slope of this line is positive. The answer is false. So if we take a look at the slope, which is our A here, we can actually see that the number, and we look at our graph, well, we can see again that the line is going down. So when we're reading it from left to right, like we did before, you can still see that downward trend in the line, which, as we learned earlier, is negative slope. So how would we calculate this though? Well, we can actually calculate this using our points. And you can see that we have a point here at 1 and 2, and we've got another point at 5 and -10. So we're going to start by looking at how the change in y, or that rise, is going. Okay? And so the first thing we're going to do is put in our y values, and you can see that we've got -10, and we're subtracting 2. That's going to give us the distance between our two y values, which is our rise. Now, you might think then that our slope is -12 because -10 minus 2 is -12. But you're forgetting that in that case, that slope actually needs how it's changing on the x-axis as well. And we're looking at how this rise changes, but over just 1 on the run. So 1 x value. All right, so to get that, we've got to subtract the x values in the same way. So we've got 5 down here minus our 1 up there to figure out what our change in the x is going to be, or our run. And you see that we've got actually -12 divided by 4, which gives us -3. That means that our slope is -3 and not -12. All right, so let's just recap what we just did there, okay? We took the slope. To find the slope, we took our two y values and we subtracted them. And it doesn't actually matter what order you subtract the y values in. What matters is that when you get to going down to the x values, you do the x's in the same order. So we would subtract our x values down here in the same order that we subtracted our y values. At the end, you divide, which is why we've done -12 divided by 4 to give us -3. So our slope is actually the division of those two values, the rise over the run. All right, another question. Which of the following are also used to refer to slope of a linear relationship? Is it rate of change, A, M, or all of the above? If you guessed D, all of the above, you're correct. All right, let's look at another relationship here, or another linear situation. Leanne is selling ice cream cones. She earns $40 selling 20 ice cream cones, and she earns $60 for selling 30 cones. How much will she earn if she sells 100 ice cream cones? Well, let's apply the same strategy as before, okay? Or let's break it down a bit. We have X is the number of ice cream cones sold, and Y is the money earned. So in other words, our independent variable is the number of ice cream cones, and our dependent variable is the money earned. And if we actually put that into a table of values, then we can generate a set of ordered pairs that we can graph. So let's see what that looks like. If I take a look at, again, number of ice cream cones has got to go in the X. So I just got to make sure that I put everything in the right spot. So here's my 20 ice cream cones, and she made $40 selling 20 of them. And then she's got 30 ice cream cones, and she made $60 selling 30. Okay, that brings us to looking at how much she's going to make per ice cream cone. Okay, so we can get that through our rate of change, that's or our slope. This is exactly what that's going to tell us, is how much she's got to charge, or in other words, how much she's going to be making for every ice cream cone sold. So in this case, you can see that when we compare we use our previous strategy and we take a look at our y values and subtract them, and we put them over our x values and subtract them again in the same order. That's going to give us 60 minus 40, and we're putting that over 30 minus 20 for 20 divided by 10, which gives us 2. So Leanne is making $2 per cone sold. When you graph that, this is what it's going to look like. And you can see here that we got our money earned again labeled on our y-axis, and the number of ice cream cones sold here on our x-axis, and then we got this nice line going up in positive slope. All right, perfect. We're ready to answer the initial question. It says, how much will she earn if she sells 100 ice cream cones? So if we just take a look at the rule for this equation, the rule is what's going to allow us to figure out how much she's going to make, or the y, when she sells. In this case, we're looking for 100 cones. So our x has got to be the 100. And we're going to multiply that x value by how much she's charging per cone. So that's where our slope or rate of change is going to come in right here. So 2 times 100, y is equal to 2 times 100. And that will result in y is equal to 200, which is $200. So Leanne, great haul there. $200 if she sells 100 ice cream cones. She's pretty happy. You might be thinking that, well, why did we have to go through this whole process right here? When I could have just taken any of my y values and divided them by my x value, and that would have given me $2 per cone anyway. So shouldn't I be able to find my slope by saying y divided by x just like that? And the thing is, in this case, it works out because this is what we call a direct variation linear relationship. So you can see how if I just follow my line down here, it actually crosses through the point 0, 0 right there. That's the origin. And when your line graph does that, or when your linear relationship does that, we've got what's called a direct variation linear relationship. So yeah, that'll work where we just take our y and divide it by our x, and we get our slope or rate of change. The thing is, they're not all like this. So we're going to look at another example where we don't have a direct direct relationship or direct variation linear relationship like we do in Leanne's situation. All right, so now we've got a situation here where it's not going to work like Leanne's ice cream cone. So we're going to have to actually maintain our strategy here because you can see that it's not starting at the origin like Leanne did. It's starting a little higher up. So this is what we call a partial variation linear relationship. And we really need a tool that's going to work in all situations. And that is what that rise over run tool is going to allow us to do. It's going to allow us to calculate slope in any situation, whether it be Leanne's direct variation situation or this situation here where we have a partial variation situation. But before we get into that, I got a question for you guys. True or false? The slope of this line is positive. The answer is true. The slope of this line is positive. And you can see that we've got this nice line going right up there. So when we're reading from left to right, it's going uphill, which is what we want in a positive slope situation. So now we've got to look at applying our strategy to calculate this slope. So I'm going to start with that table of values, and I'm going to put the points that I have. All right, so if I look at my graph, I'm going to start at the smallest x value that I've got for my points here. So I'm going to put the point at -2 and 2 in there first. And then I've got a point at 6 and 6. So we're going to put that in there. And we want to use our formula from the previous example. So you can see that we've got our rise over our run again. So y2 minus y1 over x2 minus x1. And when I plug in my ordered pairs here, this is what I get. So I end up with 6 minus 2 for the rise. And then on the run, I have 6 minus -2. And here we've really got to be careful because you see this double negative, that can trip people up. All right, you got to remember that there's already a subtraction in the formula, and then you're subtracting this negative value. So what you actually end up with here is an overall positive result, which means that we end up with, well, 6 minus 2 to give us the 4, and we've got that over what is essentially 6 plus 2 to give us 8. So our result is 4 over 8, which reduces, of course, to 1/2 or 0.5. All right, that's it for finding the slope of a line. I really hope this crash course helped you out. Now, if you want to find the initial value or the equation of a linear relationship, then please watch the second part of our crash course.